general class question pool. This will be section or class 8 of the question pool groupings. This question pool has had 8 sections in it. This will be the final one. If this is your first video, I would encourage you to go back and go through the first 7 sections, which do cover the general class question pool, which is in effect until the end of June 2019. Then will be replaced with a new question pool. Something else to remember, that these videos were created on behalf of the Clay County Area Amateur Radio Club located in Illinois, and I am Michael, KC9PHK. Let's get started with this one. First off today is subelement G9, covering antennas and feed lines. 4 exam questions will come from the 4 groups located in this subelement. First off, G9A, covering antenna feed lines, characteristic impedance and attenuation, SWR calculations, measurements and effects, as well as matching networks. First off, G9A01, which of the following factors determine the characteristic impedance of a parallel conductor antenna feed line? A. The distance between the centers of the conductors and the radius of the conductors. B. The distance between the centers of the conductors and length of the line. C. The radius of the conductors and the frequency of the signal. Or D. The frequency of the signal and length of the line. Correct answer here, A. The distance between the centers of the conductors and the radius of the conductors. G9A02. What are the typical characteristic impedance of coaxial cables used for antenna feed lines at amateur stations? A. 25 and 30 ohms. B. 50 and 75 ohms. C. 80 and 100 ohms. Or D. 500 and 750 ohms. Correct answer, B. 50 and 75 ohms. G9A03. What is the characteristic impedance of flat ribbon TV type twin lead? A. 50 ohms. B. 75 ohms. C. 100 ohms. Or D. 300 ohms. Correct answer, D. 300 ohms. G9A04. What might cause reflected power at the point where a feed line connects to an antenna? A. Operating an antenna at its resonant frequency. B. Using more transmitter power than the antenna can handle. C. A difference between feed line impedance and antenna feed point impedance. Or D. Feeding the antenna with unbalanced feed line. C. A difference between feed line impedance and antenna feed point impedance is the correct answer. G9A05. How does the attenuation of coaxial cable change as the frequency of the signal it is carrying increases? A. Attenuation is independent of frequency. B. Attenuation increases. C. Attenuation decreases. Or D. Attenuation reaches a maximum at approximately 18 megahertz. Correct answer here, B. Attenuation increases. G9A06. In what units is RF feed line loss usually expressed? A. Ohms per 1,000 feet. B. Decibels per 1,000 feet. C. Ohms per 100 feet. Or D. Decibels per 100 feet. Correct answer, D. Decibels per 100 feet. G9A07. What must be done to prevent standing waves on an antenna feed line? A. The antenna feed point must be at a DC ground potential. B. The feed line must be cut to a length equal to an odd number of electrical quarter wave lengths. C. The feed line must be cut to a length equal to an even number of physical half wave lengths. Or D. The antenna feed point impedance must be matched to the characteristic impedance of the feed line. Correct answer is D. The antenna feed point impedance must be matched to the characteristic impedance of the feed line. G9A08. If the SWR on an antenna feed line is 5:1 and a matching network at the transmitter end of the feed line is adjusted to 1:1 SWR, what is the resulting SWR on the feed line? A. 1 to 1, B. 5 to 1, C. between 1 to 1 and 5 to 1 depending on characteristic impedance of the line, or D. between 1 to 1 and 5 to 1 depending on the reflected power at the transmitter. Correct answer here is B. between 5 to 1, or 5 to 1. G9A09, what standing wave ratio will result when connecting a 50 ohm feed line to a non-reactive load having 200 ohm impedance? A. 4 to 1, B. 1 to 4, C. 2 to 1, or D. 1 to 2. Correct answer would be A. 4 to 1. G9A10, what standing wave ratio will result when connecting a 50 ohm feed line to a non-reactive load having 10 ohm impedance? A. 2 to 1, B. 50 to 1, C. 1 to 5, or D. 5 to 1. Correct answer would be D. 5 to 1. G9A11, what standing wave ratio will result when connecting a 50 ohm feed line to a non-reactive load having 50 ohm impedance? A. 2 to 1, B. 1 to 1, C. 50 to 50, or D. 0 to 0. Correct answer here is B. 1 to 1. G9A12, what standing wave ratio will result when connecting a 50 ohm feed line to a non-reactive load having 25 ohm impedance? A. 2 to 1, B. 2.5 to 1, C. 1.25 to 1, or D. you cannot determine SWR from impedance values. Correct answer here is A. 2 to 1. G9A13, what standing wave ratio will result when connecting a 50 ohm feed line to an antenna that has purely resistive 300 ohm feed point impedance? A. 1.5 to 1, B. 3 to 1, C. 6 to 1, or D. you cannot determine SWR from impedance values. Correct answer here is C. 6 to 1. G9A14, what is the interaction between high standing wave ratio and transmission line loss? A. there is no interaction between transmission line loss and SWR. B. if a transmission line is lossy, high SWR will increase the loss. C. high SWR makes it difficult to measure transmission line loss. Or D. high SWR reduces the relative effect of transmission line loss. Correct answer here is B. if a transmission line is lossy, high SWR will increase the loss. G9A15, what is the effect of transmission line loss on SWR measured at the input to the line? A. the higher the transmission line loss, the more SWR will read artificially low. B. the higher the transmission line loss, the more the SWR will read artificially high. C. the higher the transmission line loss, the more accurate the SWR measurement will be. And D. transmission line loss does not affect the SWR measurement. Correct answer here, A. the higher the transmission line loss, the more the SWR will read artificially low. G9B, covering basic antennas. G9B01 says, what is one disadvantage of a directly fed random wire HF antenna? A. it must be longer than one wavelength. B. you may experience RF burns when touching metal objects in your station. C. it produces only vertically polarized radiation. Or D. it is more effective on the lower HF bands than the higher bands. Correct answer is B. you may experience RF burns when touching metal objects in your station. Continuing on, G9B02, which of the following is a common way to adjust the feed point impedance of a quarter wave ground plane vertical antenna to be approximately 50 ohms? A. slope the verticals upward. B. slope the verticals, or the radials. A. slope the radials upward. B. slope the radials downward. C. lengthen the radials, or D. shorten the radials. Correct answer here is B. slope the radials downward. G9B03, what happens to the feed point impedance of a ground plane antenna when its radials are changed from horizontal to sloping downward? A, it decreases. B, it increases. C, it stays the same. Or D, it reaches a maximum at an angle of 45 degrees. Correct answer here, B, it increases. G9B04, what is the radiation pattern of a dipole antenna in free space in the plane of the conductor? A, it is a figure 8 at right angles to the antenna. B, it is a figure 8 off both ends of the antenna. C, it is a circle with equal radiation in all directions. D, it has a pair of lobes on one side of the antenna and a single lobe on the other. Correct answer here, A, it has a figure 8 at the right angles of to the antenna. G9B05, how does the antenna height affect the horizontal azimuthal radiation pattern of a horizontal dipole HF antenna? A, if the antenna is too high, the pattern becomes unpredictable. B, antenna height has no effect on the pattern. C, if the antenna is less than 1/2 wavelength high, the azimuthal pattern is almost omnidirectional. Or D, if the antenna is less than 1/2 wavelength high, radiation off the ends of the wire is eliminated. Correct answer C, if the antenna is less than 1/2 wavelength high, the azimuthal pattern is almost omnidirectional. G9B06, where should the radial wire of a ground-mounted vertical antenna system be placed? A, as high as possible above ground. B, parallel to the antenna element. C, on the surface of the earth or buried a few inches below the ground. Or D, at the center of the antenna. Correct answer C, on the surface of the earth or buried a few inches below the ground. G9B07, how does the feed point impedance of a half-wave dipole antenna change as the antenna is lowered below 1/4 wave above ground? A, it steadily increases. B, it steadily decreases. C, it peaks at about 1/8 wavelengths above ground. Or D, it is unaffected by the height above ground. Correct answer B, it steadily decreases. G9B08, how does the feed point impedance of a half-wave dipole change as the feed point is moved from the center towards the ends? A, it steadily increases. B, it steadily decreases. C, it peaks at about 1/8 wavelength from the end. Or D, it is unaffected by the location of the feed point. Correct answer is A, it steadily increases. G9B09, which of the following is an advantage of a horizontally polarized as compared to a vertically polarized HF antenna? A, lower ground reflection losses. B, lower feed point impedance. C, shorter radials. Or D, lower radiation resistance. Correct answer A, lower ground reflection losses. G9B10, what is the approximate length of a half-wave dipole antenna cut to 14.250 MHz? A, 8 feet. B, 16 feet. C, 24 feet. Or D, 32 feet. Correct answer here, D, 32 feet. G9B11, what is the approximate length for a half-wave dipole antenna cut to 3.550 MHz? A, 42 feet. B, 84 feet. C, 131 feet. Or D, 263 feet. Correct answer C, 131 feet. G9B12, what is the approximate length of a quarter wave vertical antenna cut to 28.5 MHz? A, 8 feet. B, 11 feet. C, 16 feet. Or D, 21 feet. Correct answer here is A, 8 feet. G9C, covering directional antennas. And here we go. G9C01, which of the following would increase the bandwidth of a Yagi antenna? A, larger diameter elements. B, closer element spacing. C, loading coils in series with the element. Or D, tapered diameter elements. Correct answer A, larger diameter elements. G9C02, what is the approximate length of the driven element of a Yagi antenna? A, 1/4 wavelength. B, 1/2 wavelength. C, 3/4 wavelength. Or D, 1 wavelength. Correct answer B, half wavelength. G9C03, what statement about a 3-element single-band Yagi antenna is true? A. The reflector is normally the shortest element. B. The director is normally the shortest element. C. The driven element is the longest element. Or D. Low feed point impedance increases bandwidth. Correct answer here is B. The director is normally the shortest element. G9C04, which statement about a 3-element single-band Yagi antenna is true? A. The reflector is normally the longest element. B. The director is normally the longest element. C. The reflector is normally the shortest element. Or D. All of the elements must be the same length. Correct answer A. The reflector is normally the longest element. G9C05, how does increasing boom length and adding directors affect a Yagi antenna? A. Gain increases. B. Bandwidth increases. C. Front to back ratio decreases. Or D. Front to side ratio decreases. Correct answer is A. Gain increases. G9C06, what configuration of the loops of a 2-element quad antenna must be used for the antenna to operate as a beam antenna, assuming one of the elements is used as a reflector? A. The driven element must be fed with a Balun transformer. B. There must be an open circuit in the driven element at the point opposite the feed point. C. The reflector element must be approximately 5% shorter than the driven element. Or D. The reflector element must be approximately 5% longer than the driven element. Correct answer is D. The reflector element must be approximately 5% longer than the driven element. G9C07 says, what does front-to-back ratio mean in reference to a Yagi antenna? A. The number of directors versus the number of reflectors. B. The relative position of the driven element with respect to the reflectors and directors. C. The power radiated in the major radiation lobe compared to the power radiated exactly the opposite direction. Or D. The ratio of forward gain to dipole gain. Correct answer here, C. The power radiated in the major radiation lobe compared to the power radiated in exactly the opposite direction. G9C08, what is meant by the main lobe of a directive antenna? A. The magnitude of the maximum vertical angle of radiation. B. The point of maximum current in a radiating antenna element. C. The maximum voltage standing wave point on a radiating element. Or D. The direction of maximum radiated field strength from the antenna. Correct answer is D. The direction of maximum radiated field strength from the antenna. G9C09, how does the gain of a 3-element horizontally polarized Yagi antennas spaced vertically half wavelength apart typically compare to the gain of a single 3-element Yagi? A. Approximately 1.5 dB higher. B. Approximately 3 dB higher. C. Approximately 6 dB higher. Or D. Approximately 9 dB higher. Correct answer B. Approximately 3 dB higher. G9C10, which of the following is a Yagi antenna design variable that could be adjusted to optimize forward gain, front to back ratio, and SWR bandwidth? A. The physical length of the boom. B. The number of elements on the boom. C. The spacing of each element along the boom. Or D. All of these choices are correct. Correct answer here is D. All of these choices are correct. G9C11, what is the purpose of a gamma match used with Yagi antennas? A. To match the relatively low feed point impedance to 50 ohms. B. To match the relatively high feed point impedance to 50 ohms. C. To increase the front to back ratio. Or D. To increase the main lobe gain. Correct answer is A. To match the relatively low feed point impedance to 50 ohms. G9C12, which of the following is an advantage of using a gamma match for impedance matching of a Yagi antenna to 50 ohm coax feed line? A. It does not require the elements to be insulated from the boom. B. It does not require any inductors or capacitors. C. It is useful for matching multi-band antennas. Or D. All of these choices are correct. Correct answer here, A. It does not require the elements be insulated from the boom. G9C13, approximately how long is each side of the driven element of a quad antenna? A. 1/4 wavelength, B. 1/2 wavelength, C. 3/4 wavelength, or D. 1 wavelength. Correct answer A. 1/4 wavelength. G9C14, how does the forward gain of a 2-element quad antenna compare to the forward gain of a 3-element Yagi antenna? A. About 2/3 as much, B. About the same, C. About 1.5 times as much, or D. About twice as much. Correct answer is B. About the same. G9C15, approximately how long is each side of the reflector element of a quad antenna? A. Slightly less than 1/4 wavelength, B. Slightly more than 1/4 wavelength, C. Slightly less than 1/2 wavelength, or D. Slightly more than 1/2 wavelength. Correct answer here is B. Slightly more than 1/4 wavelength. G9C16, how does the gain of a 2-element delta loop beam compare to the gain of a 2-element quad antenna? A. 3 dB higher, B. 3 dB lower, C. 2.54 dB higher, or D. About the same. Correct answer D. About the same. G9C17, approximately how long is each leg of a symmetrical delta loop antenna? A. 1/4 wavelength, B. 1/3 wavelength, C. 1/2 wavelength, or D. 2/3 wavelength. Correct answer B. 1/3 of a wavelength. G9C18, what happens when the feed point of a quad antenna of any shape is moved from the midpoint of the top or bottom to the midpoint of either side? A. The polarization of the radiated signal changes from horizontal to vertical. B. The polarization of the radiated signal changes from vertical to horizontal. C. There is no change in polarization. Or D. The radiated signal becomes circularly polarized. Correct answer is A. The polarization of the radiated signal changes from horizontal to vertical. G9C19, how does the antenna gain stated in dBi compare to gain stated in dBd for the same antenna? A. dBi gain figures are 2.15 dB lower than dBd gain figures. B. dBi gain figures are 2.15 dB higher than dBd gain figures. C. dBi gain figures are at the same as the square root of dBd gain figures multiplied by 2.15. Or D. dBi gain figures are the reciprocal of dBd gain figures plus 2.15 dB. Correct answer here is going to be B. dBi gain figures are 2.15 dB higher than dBd gain figures. G9C20, what is meant by the terms dBi and dBd when referring to antenna gain? A. dBi refers to isotropic antenna, dBd refers to a dipole antenna. B. dBi refers to an isospheric reflecting antenna, and dBd refers to dissipative antenna. C. dBi refers to an inverted V antenna, dBd refers to a downward reflecting antenna. Or D. dBi refers to an isometric antenna, and dBd refers to a discone antenna. A. dBi refers to an isotropic antenna, dBd refers to a dipole antenna. G9D, specialized antennas. G9D01, what does the term NVIS mean as related to antennas? A. Nearly vertical inductance system. B. Non-varying indicated SWR. C. Non-varying impedance smoothing. D. Near vertical incidence skywave. Correct answer D. Near vertical incidence skywave. G9D02, which of the following is an advantage of an NVIS antenna? A. Low vertical angle radiation for working stations out to ranges of several thousand kilometers. B. High vertical angle radiation for working stations within a radius of a few hundred kilometers. C. High forward gain. Or D. All of these choices are correct. Correct answer B. High high vertical angle radiation for working stations within a radius of a few hundred kilometers. G9D03, at what height above ground is an NVIS antenna typically installed? A, as close to half wavelength as possible. B, as close to 1 wavelength as possible. C, height is not critical as long as it is significantly more than half wavelength. Or D, between 1/10 and 1/4 wavelength. Correct answer D, between 1/10 and 1/4 wavelength. G9D04, what is the primary purpose of antenna traps? A, to permit multi-band operation. B, to notch spurious frequencies. C, to provide balanced feed point impedance. Or D, to prevent out-of-band operation. Correct answer A, to permit multi-band operation. G9D05, what is an advantage of vertical stacking of horizontally polarized Yagi antennas? A, it allows quick selection of vertical or horizontal polarization. B, it allows simultaneous vertical and horizontal polarization. C, it narrows the main lobe in azimuth. Or D, it narrows the main lobe in elevation. Correct answer is D, it narrows the main lobe in elevation. G9D06, which of the following is an advantage of a log periodic antenna? A, wide bandwidth. B, higher gain per element than a Yagi antenna. C, harmonic suppression. Or D, polarization diversity. A, wide bandwidth. G9D07, which of the following describes a log periodic antenna? A, length and spacing of the elements increase logarithmically from one end of the boom to the other. B, impedance varies periodically as the function of frequency. C, gain varies logarithmically as a function of frequency. D, SWR varies periodically as a function of boom length. Correct answer here is A, length and spacing of the elements increases logarithmically from one end of the boom to the other. G9D08, what is a beverage antenna? Why is a beverage antenna not used for transmitting? A, its impedance is too low for effective matching. B, it has high losses compared to other types of antennas. C, it has poor directivity. Or D, all of these choices are correct. Correct answer B, it has high losses compared to other types of antennas. G9D09, which of the following is an application for a beverage antenna? A, directional transmitting for low HF bands. B, directional receiving for low HF bands. C, portable direction finding at higher HF frequencies. Or D, portable direction finding at lower HF frequencies. Answer is B, directional receiving for low HF bands. G9D10, which of the following describes a beverage antenna? A vertical antenna. B, a broadband mobile antenna. C, a helical antenna for space reception. Or D, a very long and low directional receiving antenna. Answer is D, a very long and low directional receiving antenna. G9D11, which of the following is a disadvantage of multi-band antennas? A, they present low impedance on all design frequencies. B, they must be used with an antenna tuner. C, they must be fed with open wire line. Or D, they have poor harmonic rejection. Correct answer is D, they have poor harmonic rejection. Subelement G0, electrical and RF safety. 2 exam questions come from the 2 groups. First off, G0A, covering RF safety principles, rules, and guidelines, routine station evaluation. G0A01, what is one way that RF energy can affect human body tissue? A, it heats body tissue. B, it causes radiation poisoning. C, it causes the blood count to reach a dangerously low level. D, it cools body tissues. Correct answer is A, it heats body tissues. G0A02, which of the following properties is important in estimating whether an RF signal exceeds the maximum permissible exposure? A, its duty cycle. B, its frequency. C, its power density. Or D, all of these choices are correct. Correct answer is D, all of these choices are correct. G0A03, how can you determine that your station complies with FCC RF exposure regulations? A, by calculation based on FCC OET Bulletin 65. B, by calculation based on computer modeling. C, by measurement of field strength using calibrated equipment. or D, all of these choices are correct. D is the correct answer. All of these choices are correct. G0A04, what does time averaging mean in reference to RF radiation exposure? A, the average amount of power developed by a transmitter over a specified 24-hour period. B, the average time it takes RF radiation to have any long-term effect on the body. C, the total time of the exposure. Or D, the total RF exposure averaged over a certain time. Correct answer is D, the total RF exposure averaged over a certain time. G0A05, what must you do if an evaluation of your station shows RF energy radiated from your station exceeds permissible limits? A, take action to prevent human exposure to the excessive RF fields. B, file an environmental impact statement, EIS 97, with the FCC. C, secure written permission from your neighbors to operate above the controlled MPE limits. Or D, all of these choices are correct. Answer here is going to be A, take action to prevent human exposure to the excessive RF fields. G0A06, what precaution should be taken when installing a ground-mounted antenna? A, it should not be installed higher than you can reach. B, it should not be installed in a wet area. C, it should be limited to 10 feet in height. Or D, it should be installed such that it is protected against unauthorized access. Best answer here is D, it should be installed such that it is protected from unauthorized access. G0A07, what effect does transmitter duty cycle have when evaluating RF exposure? A, lower transmitted duty cycle permits greater short-term exposure levels. B, a higher transmitter duty cycle permits greater short-term exposure levels. C, low duty cycle transmitters are exempt from RF exposure evaluation requirements. Or D, high duty cycle transmitters are exempt from RF exposure requirements. A lower transmitter duty cycle permits greater short-term exposure levels. G0A08, which of the following steps must an amateur operator take to ensure compliance with RF safety regulations when the transmitter power exceeds levels specified in FCC Part 97.13? A, post copy of FCC Part 97.13 in the station. B, post copy of OET Bulletin 65 in the station. C, perform a routine RF exposure evaluation. Or D, all of these choices are correct. Correct answer here is C, perform a routine RF exposure evaluation. G0A09, what type of instrument can be used to accurately measure an RF field? A receiver with an S meter. B, a calibrated field strength meter with a calibrated antenna. C, an SWR meter with a peak reading function. Or D, an oscilloscope with a high stability crystal marker generator. The answer here is B, a calibrated field strength meter with a calibrated antenna. G0A10, what is one thing that can be done if evaluation shows that your neighbor might receive more than the allowable maximum of RF exposure from the main lobe of a directional antenna? A, change to a non-polarized antenna with higher gain. B, post a warning sign that is clearly visible to the neighbor. C, use an antenna with a higher front-to-back ratio. Or D, take precautions to ensure that the antenna cannot be pointed in their direction. Best answer here is D, take precautions to ensure that the antenna cannot be pointed in their direction. G0A11, what precaution should you take if you install an indoor transmitting antenna? A, locate the antenna close to your operating position to minimize feed line radiation. B, position the antenna along the edge of a wall to reduce parasitic radiation. C, make sure that MPE limits are not exceeded in occupied areas. Or D, make sure the antenna is properly shielded. C, make sure the MPE limits are not exceeded in occupied areas. G0A12, what precautions should you take whenever you make adjustments or repairs to an antenna? A, ensure that you and the antenna structure are grounded. B, turn off the transmitter and disconnect the feed lines. C, wear a radiation badge. Or D, all of these choices are correct. B, turn off the transmitter and disconnect the feed line. Going on, G0B, safety in the ham shack, electrical shock and treatment, safety grounding, fusing, interlocks, wiring, antennas, and tower safety. G0B01, which of the following, or which wire or wires in a 4-conductor connection should be attached to fuses or circuit breakers in a device operated from a 240 volt AC single-phase source? A. Only the 2 wires carrying voltage. B. Only the neutral wire. C. Only the ground wire. Or D. All wires. Answer here is A. Only the 2 wires carrying voltage. G0B02, what is the minimum wire size that may be safely used for a circuit that draws up to 20 amperes of continuous current? A. AWG number 20. B. AWG number 16. C. AWG number 12. Or D. AWG number 8. Correct answer C. AWG number 12. G0B03. Which size of fuse or circuit breaker would be appropriate to use with a circuit that uses AWG number 14 wiring? A. 100 amperes. B. 60 amperes. C. 30 amperes. Or D. 15 amperes. Correct answer D. 15 amperes. G0B04. Which of the following is a primary reason for not placing a gasoline-fueled generator inside an occupied area? A. Danger of carbon monoxide poisoning. B. Danger of engine over torque. C. Lack of oxygen for adequate combustion. Or D. Lack of nitrogen for adequate combustion. The best answer here is A, or the correct answer is A. Danger of carbon monoxide poisoning. G0B05. Which of the following conditions will cause a ground fault circuit interrupter to disconnect the 120 or 240 volt AC line power to a device? A. Current flowing from one or more of the voltage carrying wires to the neutral wire. B. Current flowing from one or more of the voltage carrying wires directly to ground. C. Overvoltage on the voltage carrying wires. Or D. All of these choices are correct. The answer here is B. Current flowing from one or more of the voltage carrying wires directly to ground. G0B06. Why must the metal enclosures of every item of station equipment be grounded? A. It prevents a blown fuse in the event of an internal short circuit. B. It prevents signal overload. C. It ensures that the neutral wire is grounded. Or D. It ensures that hazardous voltages cannot appear on the chassis. Correct answer D. It ensures that hazardous voltages cannot appear on the chassis. G0B07. Which of the following choices should be observed when climbing a tower using a safety belt or harness? A. Never lean back or rely on the belt alone to support your weight. B. Confirm that the belt is rated for the weight of the climber and that it is within allowable service life. C. Ensure that all heavy tools are securely fastened to the D-ring. Or D. All of these choices are correct. Correct answer is B. Confirm that the belt is rated for the weight of the climber and that it is within allowable service life. G0B08. What should be done by any person preparing to climb a tower that supports electrically powered devices? A. Notify the electric company that a person will be working on the tower. B. Make sure all circuits that supply power to the tower are locked out and tagged. C. Unground the base of the tower. Or D. All of these choices are correct. Correct answer here is B. Make sure all circuits that supply power to the tower are locked out and tagged. G0B09. Why should soldered joints not be used with the wires that connect the base of a tower to a system of ground rods? A. The resistance of solder is too high. B. Solder flux will prevent a low conductivity connection. C. Solder has too high a dielectric constant to provide adequate lightning protection. Or D. A solder joint will likely be destroyed by the heat of a lightning strike. Best answer here, and the correct answer, is D. A solder joint will likely be destroyed by the heat of a lightning strike. G0B10. Which of the following is a danger from lead-tin solder? A. Lead can contaminate food if hands are not washed carefully after handling the solder. B. High voltages can cause lead-tin solder to disintegrate suddenly. C. Tin in the solder can cold flow, causing shorts in the circuit. Or D. RF energy can convert the lead into a poisonous gas. Correct answer is A. Lead can contaminate food if hands are not washed carefully after handling the solder. G0B11, which of the following is a good practice for lightning protection grounds? A. They must be bonded to all buried water and gas lines. B. Bends and ground wires must be made as close as possible to a right angle. C. Lightning rods must be connected to all ungrounded wires. D. They must be bonded together with all other grounds. Correct answer is D. They must be bonded together with all other grounds. G0B12, what is the purpose of a power supply interlock? A. To prevent unauthorized changes to the circuit that would void the manufacturer's warranty. B. To shut down the unit if it becomes too hot. C. To ensure that dangerous voltages are removed if the cabinet is opened. Or D. To shut down the power supply if too much voltage is produced. Correct answer is C. To ensure that dangerous voltages are removed if the cabinet is opened. G0B13. What must you do when powering your house from an emergency generator? A. Disconnect the incoming utility power feed. B. Ensure the generator is not grounded. C. Ensure that all lightning grounds are disconnected. Or D. All of these choices are correct. Correct answer here is A. Disconnect the incoming utility power feed. G0B14. Which of the following is covered by the National Electrical Code? A. Acceptable bandwidth limits. B. Acceptable modulation limits. C. Electrical safety inside the ham shack. Or D. RF exposure limits of the human body. Answer here is C. Electrical safety inside the ham shack. G0B15. Which of the following is true of an emergency generator installation? A. The generator should be located in a well-ventilated area. B. The generator must be insulated from ground. C. Fuel should be stored near the generator for rapid refueling in the case of an emergency. Or D. All of these choices are correct. Correct answer here is A. The generator should be located in a well-ventilated area. Alright, and that concludes video number 8. Thank you for following along. Hopefully that these slides will help you out. So hopefully these videos have been beneficial for you. Again, there are 8 of them. We also have the technician class if you're looking for those. And I would encourage you to keep studying those until you pass your test. Let us know how you did. On behalf of the Clay County Area Amateur Radio Club, thank you for joining us.